This video is going to go through the solutions to your test review questions. So we start with the graph, and it says to find the domain, the zeros, and behavior. So when you're looking at your graph, the things that stop your domain are your vertical asymptotes and your holes. So it's going to go from negative infinity because this arrow is here, starts at negative infinity, and then it stops with your vertical asymptote, which is at 4. And then it actually picks up again after 4, but it stops at the hole that's 5. So then it goes from 4 to 5, and then it stops again at 5, and then it picks back up at 5, and it goes to positive infinity. The 0 is 3, where it hits the x-axis. The end behavior in limit notation, so the limit as x approaches negative infinity and the limit as x approaches positive infinity, remember, is based on your horizontal asymptote. There's a horizontal asymptote that runs through 1, so both the left and the right hand side of this would be 1. D says find the limit notation of the vertical asymptote. So we have a vertical asymptote at x equals 4. So we're going to find the limit as x approaches 4 from the left and the limit as x approaches 4 from the right. From the left-hand side, my arrow is pointing up, which means it's going to positive infinity. And from the right-hand side, as it approaches 4, it's also going up, which means the right-hand side, or as it approaches from the right, is also going to positive infinity. And then our hole, to describe the hole, we want the coordinates, which is 5, 4. So the limit as x approaches 5 from the left and the limit as x approaches 5 from the right are both the y coordinate of the hole, which would be 4. Now it's asking you to answer questions based on the actual equation of the function. So the first thing we're going to do is factor both the numerator and the denominator. In the top, I can take out an x, and I'd get x squared minus 2x minus 15. And then I can factor that further by doing x minus 5 and x plus 3. And then in the bottom, it'd be x plus 3 and x minus 2. So my domain comes before I cancel anything out. Set my denominator not equal to 0, and I get that x cannot equal negative 3 or 2. So it'd be negative infinity to negative 3, negative 3 to 2, and 2 to positive infinity. Then I cross through that x plus 3, which means I'm creating a hole. So the x coordinate of my hole is negative 3. And then all the other things after this, I use my updated function for. So when I want to find the y coordinate of the hole, I plug it in after, which would be negative 3, times negative 3 minus 5 over negative 3 minus 2. And I get negative 3 times negative 8 over negative 5, or 24 over 5. The 0 comes from my numerator after I simplify. So my new function is x times x minus 5 over x minus 2. If I split and solve my numerator, I get 0 and 5 for the zeros. The y-intercept comes from plugging in 0 into, again, the updated function, into all the x values. So I'd get 0 times 0 minus 5 over 0 minus 2. The numerator is 0, denominator is negative 2, so 0, 0 is my y-intercept. The horizontal asymptote, if I compare the numerator and the denominator of my updated function, this would be an x squared, and the denominator would be an x. The n is bigger than the m, so there is no horizontal asymptote. The n is 1 bigger than the m, so there would be slant. So I'm going to distribute this. I'd get negative 5x over x minus 2. And then I'd want to divide that out. You can do long division. I would suggest synthetic because it's easier, and it's an x plus or minus. So the opposite of what follows x goes on the outside, and I list my coefficients, which would be 1, negative 5, and 0, because there'd be a plus 0 there. Bring down the 1. Multiply by 2, put it in the next column and add it. Multiply by 2, put it in the next column. I don't need my remainder. What I need is the x in front, or the x on the first term, and to put it into y equals mx plus b form. So this would be y equals x minus 3. And then on the bottom over here on the left, it says find your vertical asymptotes. That's after I cancel things out. I would set my denominator equal to 0. I get x equals 2. All right, from the top here, it says use the table of rational functions to do the following. So first of all, make sure you'd be able to plug in these values using a graphing utility if you were given the function. This time they gave you the function, so we're looking at these values. It says find the limit as t approaches -3 from the left. So if I look at these values, -3 is the middle, obviously. -3.001 is less than. So if I was coming to -3 from the left, that's what it would look like. This is coming from the left. What's happening to these values? They are increasing without bound. So this would be positive infinity. As I'm approaching -3 from the right, which would be coming this way, what's happening to these values is they are decreasing without bound. So this would be negative infinity. So as t approaches -3 from the left, the d of t increases without bound. And as it's approaching from the right, it is decreasing without bound. Because they are increasing and decreasing without bound, I would assume that there is a vertical asymptote at x equals -3. All right, now we're going to do the binomial theorem to expand. So first of all, it's a 5. I'm going to do my Pascals to get my coefficients. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. So this is the row I'm going to use when I expand. So I can do 1, 5, 10, 10, 5, and 1. And then I'm going to take my first term, starting with the 5 and decreasing. So x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0, which would really be just 1. And take my second term and go the opposite way. So 3 to the 5th. No, sorry, 3 to the 0. 3 to the 1st. 3 to the 2nd. 3 to the 3rd. 3 to the 4th, and 3 to the 5th. And then I multiply them all out. So 3 to the 0 is 1. This is just x to the 5th. This would be 5 times 3, or positive 15, x to the 4th. This would be 9 times 10, positive 90, x to the 3rd. This would be 27 times 10, so positive 270, x to the 2nd. And this would be 81 times 5, or 405, x to the 1st. And then this is 1, and this becomes 243. So it's plus 243. This is your expansion. Now for 5, it wants you to go to the 7th power. So I'm just going to take this and I'm going to add to it. I would get 1, 6, 15, 20, 15, 6, 1, and 1, 7, 21, 35, 35, 21, 7, and 1. So this is the one I want. And I want the 5th term. So as I go from left to right, this would be 1, 2, 3, 4, 5, 35. This 35 is my 5th coefficient. So I get 35. And then if you think about what's happening, if it's the 5th term in 7, then it would start as 2x to the 7th, to the 6th, to the 5th, to the 4th, to the 3rd. So first term, second term, third term, fourth term. 5th term would be 2x to the 3rd. And then I go the other way with the -1. It would be 0, 1, 2, 3, 4. And remember, these two have to add up to that 7. So it would be -1 to the 4th. So then I get 35 times 2 to the 3rd times x to the third times negative 1 to the fourth. 35 times 8, x to the third times 1. And 35 times 8, 280, x to the third. All right, looking at number 14, it says the rational function f is given by this function, where k is a positive integer. If the function f has a slant asymptote, what's the value of k? So we know that in order for there to be a slant asymptote, the exponent in the top has to be one more than the bottom. So I know that the degree in the top is 5, which means the sum of these exponents has to be 6. So if this is x to the first and x to the first, then I need k to be to the fourth, because x to the fourth times x to the first times x to the first is going to give me x to the sixth. So 4 is the answer you're looking for there. Number 5 says the rational function g is given by, which of the following describes the end behavior of g? So end behavior is based on my horizontal asymptote. The highest exponent in the numerator is 5. In the denominator, this would end up being x squared. This is x to the first and x to the first, so the denominator is x to the fourth. Which means there is no vertical or no horizontal asymptote. So I would at least need to expand to find the leading term in the denominator. So again, this would be x to the first. This would be x to the second. This would be x to the first. So my leading term is actually going to be x to the fourth. I take just the leading terms in the numerator and the denominator. I simplify, so it would just be 3x. And then the end behavior as I go, as it increases without bound means that it's going to positive infinity. As it decreases without bound means it's going to negative infinity. So if I want to know what's happening as it increases without bound, I would plug in positive infinity. This is going to stay positive. So as it increases, the f of x also increases. So increases and increases is what I'm looking for. Increases and increases. Increases and decreases doesn't work. Increases and decreases doesn't work. Then on the left-hand side, now we're talking about the x values decreasing. So as it decreases, I plug in my negative infinity and I would get negative infinity. As it decreases without bound. So decreases and decreases would be b. Number 16 gives you the values from the table. And again, it says which best describes it. So we want to look at what's happening as our x's are approaching 2 from the left and from the right-hand side. This is getting closer to 1.5. This is getting closer to 1.5, but neither's hit it. So it's skipping over that, which means there is a hole. The x coordinate of my hole is 2, and the y coordinate of my hole will be 1.5 or 2 3/2. So it definitely has a hole at x equals 2. It does not have a vertical asymptote. They would increase or decrease without bound. It has a hole where x is 2 and y is 3.2 or 3 over 2, which means that one's not true, and it does not have a vertical asymptote at 3 over 2. So A is the answer is looking for there. Okay, these last examples are using the graphs of f of x and g of x to answer questions. So number 17 says, the function r is defined by f of x over g of x. What's the value of r of 0? So if I wanted to find the exact equations of these, for the linear one, I could, because I have my y-intercept, which is your b, and I could count my slope. This is a rise of 3 and a run of 2. So the equation of the f of x could be 3/2 x plus 3. Now, on the right-hand side, I've got a parabola. I have my intercepts, and I know it points down, so I can say negative, and I can say x plus 2 and x minus 3 would be my intercepts. But what I don't know is if there's a scalar multiple on here. So it wouldn't be possible to find the exact equation for that one. But we don't need it, because what it's asking for is r of theta, which really just means find f of 0. Find r of 0. Which means find f of 0 and g of 0. So f of 0 is 3, because I'd go to where x is 0 and I'd grab that 3. And g of 0 is also 3, so I'd go to where g is 0 and it would be 3. So I know f of 0 over g of 0 would be 1. 18 asks for the vertical asymptote. So this is where I would need to know where these equal 0, but a scalar multiple wouldn't matter because it would just be a solid number and it doesn't matter. I could get rid of it. It would never equal 0, so I can ignore those. And I would say that x equals -2 and x equals +3 would be my vertical asymptotes. Another thing it could ask you about is your zeros. So if it asked you of the zeros of the function, we'd be focusing just the numerator. We'd say 3 over 2x plus 3 would equal 0, and 3 over 2x would equal -3, and then I'd multiply by 2/3, and x would equal -2. So that's another way, another type of question they could ask on a question like this.